Welcome to Ask and Learn.
So we have a circuit with one capacitor and two springs, like this. So these are springs, not inductors. I have a spring constant K. The separation distance is 8 millimeters. And the capacitance originally, before the switch is closed, is 2 microfarads. Now, okay, we also have 100 volts. And we want to figure out the charge on the capacitor after the switch is closed. So once the switch is closed, the separation distance is cut in half. So if we take the new capacitance, it's going to be 1/2 the separation distance, means that the new capacitance, I'll just say C2, I guess. It's going to be 2C. Which is 4 microfarads. So the charge on the plates is the new capacitance times the voltage, which is 2C times V, and that's 4 times 10 to the minus 6 farads, which is 4 microfarads, times 100 volts. That gives us 400 times 10 to the minus 6 coulombs, which is 4 times 10 to the minus 4 coulombs. Now, to figure out the spring constants, we need to use some forces. So the force on either plate is going to be Q times the field. But either plate only contributes half the field to the total field between the plates. And that's going to equal Kx. And x is going to be, well, the plates have to move a total of 4 millimeters. So either plate is moving 2 millimeters on each side. So the springs are going to increase by 2 millimeters in distance. So now, let's see, E is sigma over epsilon naught, but for either plate it's only 1/2 that, because they're each going to contribute exactly half the total field. So this is Q times, and then sigma is Q over A. Okay, so this is going to be Q squared over 2 epsilon naught A. But Q, we already know, is 2C times V. So 2CV squared divided by 2 epsilon naught A. This is 2 times C squared times V squared, and 2 is already canceled out, so over epsilon naught A. But we can take a C out of here. And we know that C is epsilon naught A over D, which is the original separation distance, times V squared over epsilon naught A. So this is going to be 2C times V squared over d, and that equals kx. And x is 2 millimeters, C is 2 microfarads, V is 100 volts, and D is 8 millimeters. So this is going to be 2 times 2 microfarads, which is 2 times 10 to the minus 6 farads. The voltage is 100, that's squared. I'll solve for K, so we'll divide by X. D is 8 millimeters, which is 8 times 10 to the minus 3 meters, and X is 2 millimeters. So we get K is 2500, which is 2.5 times 10 cubed newtons per meter, which is 2.5 kilonewtons per meter.